dear students of class 10. Today we are going to start with the new chapter, and this chapter is very important. If you take this chapter, deals with class 11, class 12 and also higher classes. So here is the foundation for organic chemistry. So I request all of you to watch this video carefully and attentively. Now, organic chemistry deals with carbon and the study of carbon compounds, mainly carbon forming compounds with hydrogen, oxygen, okay, and also some other elements. Now let's discuss about organic chemistry in more detail. What you have to remember here is carbon is the central point in organic chemistry, and we are going to deal about carbon. Hence we need to know the properties of carbon. Why only carbon out of so many elements in the periodic table? Now mainly there are two properties of carbon. The first one is tetravalency of carbon. Tetravalency of carbon. Tetravalency means its valency is 4. Carbon, you know, its atomic number is 6, hence its electronic configuration is 2, 4. Now in this carbon compound, whenever carbon has to form compound with other elements, its octet has to be fulfilled. And from your knowledge of first and second chapter, you know, here carbon has to form 4 bonds with other atoms to be octet, and this is possible only by sharing of electron. That means carbon forms covalent bond. Okay, so from its electronic configuration, carbon has how many electrons in the valency? 1, 2, 3, 4. So to be octet, it needs how many more electrons? Say some other elements are present, some atoms of the elements are present, say hydrogen. The simplest of all, it has 1 electron. 1, 2, 3 and 4. This cross sign is the electron of each hydrogen. Okay, so whenever this carbon forms these covalent bonds with 4 other hydrogen atoms, then you can see its octet, the octet of carbon is complete. Hence carbon forms tetravalency. It shows tetravalency, and because of which carbon forms so many compounds. Okay, is that clear? One more point I would like to emphasize on is, for the formation of covalent bond, the electronegativity difference between the combining atom has to be almost equal or only slight difference in that. Therefore, carbon and carbon can form bond with each other, and this property is discussed in the next point, that is catenation. So let's discuss about catenation now. The second property of carbon, due to which it forms such a large number of compounds, is catenation. Catenation. So catenation is what? It's the property of any element, and here in organic chemistry it's particularly carbon, to form bonds with itself, and it can, so that it can exist in a long chain. It could be branch chain, it could be in ring form also. Okay, so what is catenation? Catenation is the property by virtue of which an atom of the element, and here it's carbon, since we are dealing with organic chemistry, to form long chain with itself, and it can form branches as well as what? The ring compounds. Okay, so here see, you can see carbon can form long chain, and you have to remember the valency of each carbon has to be 4. So this side it could be carbon, this side also it could be carbon, it could be hydrogen, and this side you can have hydrogen or carbon. That depends upon the compound about what we are discussing. So this can be elongated in this direction as well as this direction also. So this is a straight chain, and it can also form the branch chain. So instead of carbon going in a straight chain, it could be carbon this side also. So this is the branch chain. The other way in which it can exist is in the ring form. 1, 2, 3, 4, 5, 6. It could form 3-membered ring, 5-membered ring, 6-membered ring, etc. So these 2 points, tetravalency and catenation, is very important and included in your ICSE syllabus. Please, for this topic, you have to refer to page number 184. Now let's discuss more about organic chemistry. And whenever we talk about organic chemistry, particularly in ICSE level, carbon's compound with hydrogen is of much importance. So let's discuss about hydrocarbon. Okay, first, so this, whatever we are going to discuss now, is very important. Please, I want you to focus here. Hydrocarbon. So we have hydrocarbons. Now, these hydrocarbons can be again divided into different groups. You can refer for that to page number 185. But here I am concerned more about what is there in your syllabus and from where the questions will be asked in your ICS. So hydrocarbons are compounds which are formed of hydrogen and carbon only. Hydro means hydrogen and carbon means carbon. So whenever these 2 are compounds, these 2 elements, these 2 atoms of the element, they combine to form a compound, then that compound is known as what? Hydrocarbon. As I told you, the most important part that is included in your ICSE, we'll be discussing that. So that is aliphatic hydrocarbon. There is a division of hydrocarbon. For that, please refer to page number 185. And now we are going to discuss about aliphatic hydrocarbon. And under aliphatic hydrocarbon, saturated hydrocarbon and unsaturated hydrocarbon. So under hydrocarbon, you have this aliphatic hydrocarbon, and this aliphatic hydrocarbon is divided into 2 categories. One is saturated hydrocarbon, the other one is unsaturated hydrocarbon. Now this saturated hydrocarbon, we'll be discussing that in detail. This unsaturated hydrocarbon is further divided into 2 types, and that is alkenes and alkynes. Okay, so this is alkenes and this is alkynes. This saturated hydrocarbon is alkane. So you have to remember this name: alkanes, alkenes and alkynes. Look at the spelling here: ANES, this is ENES, this is YNES. So the general formula for alkane is CnH2n. The general formula for, let me write it here, it may not be visible here in the video. So here it is CnH2n plus 2. So this is the general formula for alkane. Please don't worry, I'll be explaining this part also. Alkane is CnH2n, and this alkynes is CnH2n minus 2. Okay, so you have to remember this. Now let's discuss about this general formula. So let's discuss about this general formula first. Alkanes, that is CnH2n plus 2. So now hydrocarbons, in hydrocarbons, if you want to have an alkane compound, then this N denotes the number of carbon atom. Okay, suppose in a formula you have say 2 carbon atoms. Okay, now for this compound, this hydrocarbon to be alkane, what should be the number of hydrogen? This N denotes the number of carbon atom, 2. So 2 into 2 plus 2. This will give you as C2H6. So now whenever you have this formula, then this formula satisfies this general formula, then this compound is your alkane. Now let's take alkene. Alkene is CnH2n. So let's take the same number of carbon atom, 2. So for this compound to be alkene, what should be the number of hydrogen? Hydrogen should be, the value of N is same, 2. So C2H4. Now this compound will give you, this is alkene. And what is the general formula for alkyne? CnH2n minus 2. Here also let's take the number of carbon as 2. Hydrogen should be 2 into 2 minus 2. So you will be having C2H, 4 minus 2 is 2. So look at this example, very important. C2H6 is your alkane, C2H4 is your alkene, and C2H2 is alkyne. Now in a simple way, you can remember this way also. This is how I used to remember when I was a student in class 10. Whenever you have, I started with the middle portion. This is alkene. Alkene, alkene, alkyne. Alkene, alkene, alkyne. The number of hydrogen should be exactly the double of carbon atom. If that is the case, hydrogen is double the number of carbon atom. That means that is alkane. Is it alkane? No, it is alkene. Okay, alkene. Remember that, alkene. 2 more than double, exactly double. What is double? The number of hydrogen atoms. Now here, for a compound to be alkane, the number of hydrogens should be 2 more than the double, the number of carbon atoms. If that is the case, that is alkanes. And if the number of hydrogen is 2 less than that of the alkane, then that would give you alkyne. So here C2H2. That means the number of hydrogen atom is 2 less than its double. Because of that, this is what? Alkyne. So this is how you have to remember. Now, let's go. This is like a family. Like you have alkene. Under that you have so many compounds. With 1 carbon atom, it has a different name. With 2 carbon atom, it has a different name. So let's discuss about this part. Okay, this part is very, very important. This is like the naming. This is how. This is here. I'll tell you how those organic compounds are named. Okay, the basic one, the alphabets you can say. Organic chemistry is interesting. It becomes interesting if these fundamental concepts are well understood. If not, then it becomes very difficult for you to understand the upcoming topics. Therefore, I tell you to go through this video, and if any problem regarding this organic chemistry, since it's new to you all, please ask me. You have my WhatsApp number. Now let's discuss the number of carbon atoms. Okay, number of carbons. This is carbon atoms. Now for this compound to be alkane, what should be the name? If it is alkene, what is its name? And if it is alkyne, what should be its name? So with one carbon, see, number of carbon atoms means in the compound of hydrocarbon, if the number of carbon atom is 1, that means only C1 is present. Then the name starts with meth. So one more column would make it more easier. So number of carbon atoms here, carbons, and here name, starting name. Okay, so if you have one number of carbon atom, then its name starts with meth. If 2, then it is eth. You have to remember this portion. If it is 3, then it becomes prop. If it is 4, it becomes but. And if it is 5, it is pent. So others are also there. So if you remember this, so for the beginning, this, if you understand it, you will be able to understand further. Now, for a compound containing one carbon atom, suppose you have said, this is an example, one carbon only. So its name starts with what? Meth. And if there is only one carbon atom, then it can form only alkene, not alkene and alkyne. So this is not possible. Its name will be meth, ANEN. So don't forget, this is included here. Methane. Okay? With one carbon atom, alkene and alkyne is not possible. If two carbon atom, it is eth. And if it satisfies this general formula, that is CnH2n plus 2, the number of hydrogen atoms, then its name would be ethane, YN alkane. Now if it satisfies this general formula, CnH2n, then its name would be eth alkene, no? E-N-E, ethene. Okay, and if it satisfies this general formula CnH2n minus 2, then its name would be what is here? Wine, Y-N-E. Very simple, ethyne. So you just have to remember this portion first and the general formula. Please don't forget that. With prop, it would be, if it satisfies this general formula of alkane, then it is propane. And if it satisfies the general formula of alkene, that is CnH2n, then it becomes propene. And if it satisfies the general formula of the CnH2n minus 2, then it becomes propyne. Let's take one example. This two you can do it. You can easily do it if you remember. But in butyne, pent in wine, pentyne. Okay. So let's take one particular example and see for your better understanding. Let's take a compound with say 3 carbon atoms. 1, 2, 3. Now 1, 2, 3, 1, 2, 1, 2, 1. So these are all hydrogens. Why I'm writing hydrogen over here? Don't forget, each carbon atom forms 4 covalent bonds. So see, one carbon, 1, 2, 3, 4. For this valence is satisfied. For this carbon, 1, 2, 3, 4. Its valence is satisfied. For this carbon, 1, 2, 3, 4. Its valence is satisfied. So if this is the molecular formula, you can count the number of carbon atoms. C3. How many hydrogens? Please count it. It is 8. So with general formula it satisfies. Exactly double or 2 more than the double. If it is double, 6, 2 more than the double, no? So this is alkane, hence its name is propane. This is clear, very easy. C3H6, had it been H6, alkene, 2 more than the double, this is alkane. And in particular, how many carbon atoms are there? 3. With 3, you have, your name has to start with propane. Okay? Very interesting and easy also, if you follow these rules. One more thing I would like to say here is, this alkenes, it contains double bond. Okay? In a compound of alkene, it contains double bond. In a compound of alkyne, it contains triple bond. Now with the same formula of propane, you have 1, 2, 3, 1, 2, 3 hydrogen, 1, 2, 3. This was your propane. These are all your hydrogens. This is your propane, no? So for a compound of 3 carbons to be propene, there has to be presence of a double bond. Then what should be the number of, see, with 3 carbon atoms, for this compound to be alkene, the number of hydrogens should be double, so there should be 6 hydrogens. Now let's try to find the structure of this one. So 1, 2, 3 carbons, and as I told you, there has to be a double bond. Okay? Now fulfill the valency of this carbon, each carbon, 1, 2, 3 and 4. Here 1, 2, 3. Already it has, so 1 hydrogen. And here this carbon has 2 bonds, and it can form 2 more bonds with hydrogen atom. Now please kindly count the number of hydrogen atom. 1, 2, 3, 4, 5, 6. And don't forget, it contains double bond. And double bond, this is the formula for propene. This is the formula for propene. Now for this particular compound to be propine, then it should contain what? Triple bond. And its formula would be C3H Cn S2n minus 2. That means if it is 3, it would be 6 minus 2, 4. 2 less than its double. So this is alkyne. And in particular, since it has 3 carbon atoms, it is propine. So let's draw its structure. 1, 2, 3 carbons. 3 carbons done. Propine should contain triple bond. So 1, 2, 3 triple bond. Now let's fulfill the valency of each carbon atom. This carbon has 1 bond, so it can form 3 more bonds, that to be tetravalent. This carbon, look at the middle carbon, 1, 2, 3, 4. Its valency is already satisfied, so it cannot form any more bond. This carbon, the first carbon, 1, 2, 3, it can form 1 bond. Now this is the formula for propyne. Okay, so with this we come to the end of today's class. In the next class we will be discussing organic chemistry in more detail. Please kindly, humble request, revise it. Watch it properly. If you don't understand for the first time, watch it second, and even after that if you don't understand, please ask me. Okay, I'm always there. Thank you.